Hi, my name is Sebastian Matteau, and today I would like to tell you everything there is to know about exception handling in Python. Now, if you've ever done a little bit of Python coding, then you have some idea probably of what exceptions are, because they are just the error messages that you get when you make a mistake in your Python code. But Python has a very elaborate system for dealing with exceptions, for dealing with these error messages, far more elaborate than most people are aware of. And in this video, I would like to show you a few cool, but most importantly, very useful tricks for dealing with exception messages. Now, let's start with the very basics so that we know what exceptions are. If you have a Python script, you can get two kinds of error messages, basically syntax errors and exceptions. And a syntax error is what you get when you write a script, or you want to write a script, but it's actually not syntactically valid Python. So if I say if x is 0, print x is 0, this is not syntactically valid Python. It's close, but it's not quite syntactically valid Python, because I'm using a single equal sign here, whereas of course it should be a double equal sign. So if I try to run this, I get a syntax error. And a syntax error is not an exception message. Nothing is being executed here. It is just a Python interpreter saying that this is actually not a Python script. And the only way to deal with syntax errors is to fix your code so that it is syntactically valid Python. In this case, just changing the single to a double equal sign. Now, if I run the code now, I still get an error message, but now the error message results from Python trying to execute this syntactically valid piece of script and discovering that there's actually a problem. Namely, the value x that I'm using here has not been defined, and so we get a name error, and that is an exception, right? So we have a syntactically valid piece of Python, but it is logically invalid. There's a problem with it, and that's an exception. Now, and how can we deal with exceptions? To illustrate that, let's define a very simple function that is unsafe. So I will call it 1/, and 1/, takes an integer value, and what it does, it simply returns 1 divided by that integer value. So if I run 1/2, I get half, because 1 divided by 2 is a half, right? So that's fine. But if I do 1/0, I get a 0 division error, because 1 divided by 0 is not allowed, right? We cannot divide by 0. And then we get an exception, and this particular exception is called a 0 division error. Right, so you see that there are different kinds of exceptions. Here above we saw a name error, and here this time we get a 0 division error. Both are exceptions, but they're different kinds of exceptions. Also, if we try to do 1/x, for example, the string x, we get a type error that results from us trying to divide the integer 1 by the string x, which is also not allowed. Right, so our 1/, function works in some cases, for some forms of input, but for other types of input it actually raises an exception. And it can generate at least two exceptions, a type error and a 0 division error. So how can we handle those? Well, the most basic way to catch errors, right, to deal with errors, is to put your function call in a try except block. So it's 1/, so 1/2, for example, except print an error occurred, print I. Now, so what you see, the logic here is basically we try to execute 1/. If an error occurs, then we enter this except block, we print an error occurred, and at the end we print I. Now, so just to illustrate that the except block can be executed, if I try to do 1/0, we get print an error occurred. Now, this is called a blank except statement, which is not really considered good practice because it catches every possible error that can occur. So, and if you have some idea of what kind of error you can expect, it's better to be specific about it, right? So we know that we can get a 0 division error, right? We've seen that. So then we can say, instead of just catching all possible exceptions, we catch only the 0 division error, and then we say, cannot divide by 0. Exclamation mark. Cannot divide by 0. Now, this is not complete, right? Because we can get another type of error exception if we try to operate on a string, and we don't catch that one yet. So we can add a second except block, and we can say except type error can only divide by integers. Up, right? So we can specify multiple exceptions and catch them in separate exception blocks. We can also, if we want to be a bit more concise, we can also just catch them together. We can say type error, comma, zero division error. Right, so we just lump them together and we say a problem occurred. Right, so we're a little bit less specific than we were before, but we're still only catching type errors and zero division errors and not catching all possible exceptions, which is often considered bad practice. Right, so this is how a try except block works. What we can also do is say as E. What this means is that the exception, which is an object, right? It's like everything in Python, the exception is an object, is called E. So we create a variable E that contains that refers to the exception object. And then we can use that, for example, to provide a little bit more information. You can say a problem occurred, namely, and then we print out the error message, right? So we get the exception message, unsupported operand types for hub. And if we do it for the zero division error, we get a slightly different error message. So that's often useful. One thing to take into account if you do this is that this E only lives in the except block. So if I try to print it out here, for example, you will see that at least in Python 3, the variable E is not defined there, right? So the scope of E is really only this except block, which is a little bit unusual maybe, and it actually can, it's quite a known source of bugs. Okay, now let's take this piece of code. What else can we do? Let's zoom in on the zero division error for now, right? Say that we want to do something. If a zero division error occurs, we want to do something, namely just print out cannot divide by zero. But we don't want to just throw the exception away. Then what we can do is simply do a blank raise afterwards. And then what will happen if I run this? We will print out cannot divide by zero. And then we get to this raise statement and it will simply re-raise from the dead, so to speak, this zero division error that we caught initially. Right? So this allows you to do something, to catch an error message, do something, and then raise the error message again so that it continues to propagate through your code. I would say that this is actually better done using a finally block that I will demonstrate in a minute, but it's possible. In Python 3, it can be even a little bit more fancy using the raise from syntax, but this only works in Python 3. And the way it works is what you can say, okay, value, for example, say if the value 0 is invalid, right, for our function 1 over. So it makes sense to give a value error for it. So I say, okay, if a zero division occurs, we get a value error, and the value error has the message cannot divide by 0. Right? It's an invalid value for our function. This works, right? We get value error cannot divide by 0. We can also see our Python already tells us, only Python 3 by the way, tells us that this value error that we get here is related to the zero division error that we caught here. Right? So we can sort of trace the relationship between these two error messages. We can make this a little bit more formal by saying raise value error from E. So what we are doing then is say, okay, we have this zero division error E, and we raise a value error from E. And what that means is basically that we indicate that this value error is a direct result from the zero division error that we caught before. And if I run this, you will see it actually doesn't change that much in the output, but the exact error message changes a little bit. And now we get the above exception, right? So zero division error was the direct cause of the following exception, value error. Now this is very nice because if you've been using exceptions in Python 2, then quite often you get into the situation where you catch an exception and maybe you raise another exception and you kind of lose track, right? Some of the exceptions become hidden in your code. And here, with this, especially with this raise from syntax in Python 3, you can very nicely trace back where all your exceptions originate from. That's really very useful. But again, only Python 3. Now, there's also, I will copy this up. There's also a very useful else clause. What else means is that everything in the else clause is executed if no exception occurred. So basically, no exception occurred. So let's change this, print cannot divide by 0. Now, if I run this, you will see now it says cannot divide by 0 because I'm trying to do 1 over 0. If I do 2, it will print out no exception occurred, right? So the else block is basically what is executed if everything went okay, which is different from, many people think that this is actually the same as just putting this code right behind the try except statement, and in some cases it is, but it's not always the same, right? Because this will also be executed when a zero division error occurs, right? So it is quite a useful syntactic trick in Python. And then there's even another block, the finally block, and that one is especially useful. So the finally block is always executed regardless of whether an exception occurred or not, right? So this is always executed. So no exception occurred and this is always executed. But if I do 0, cannot divide by 0, this is always executed. If I raise an exception that is not caught, right, because we are not catching type errors, you see that the finally statement is still executed, right? So the program crashes because a type error is raised and we don't catch it, but the finally statement is still executed, the finally block. Now, and the finally block, for this reason, is very convenient for doing some kind of cleanup action, right? So say that, for example, you have a connection to a database open and some kind of error occurs while working with the database, then this finally block allows you to, for example, close the connection to the database in a clean way before your program crashes. So that's really very, very useful. So basically, those are the components, the 4 blocks that you have as part of a try except statement, right? You have the try block, where you put the code that you're trying to run. You have the except block. You can actually have multiple except blocks if you want, which are executed when a particular exception occurs. We have the else block, which is executed when no exceptions occur, and the finally block, which is always executed. Even, for example, if this were a function and we would do a return in the try block, then the finally block would still be executed, right? So it's really finally always. Now, so far, we've basically looked at exceptions that are raised because we make a mistake, right? And that is the most common scenario for most people in which you will encounter exceptions. But you can also raise exceptions yourself. For example, if you have a function and that function expects particular kinds of arguments and it receives a wrong kind of argument, then you can have the function raise an exception. Say, for example, that we have a factorial function. Now, what is the factorial function? That's a very standard mathematical operator, right? For just by example, factorial 3 is 3 times 2 times 1 is 6. Factorial 4 is 4 times 3 times 2 times 1 is 24, etc. And we can implement this as follows. It's very simple. We say return 1 if n equals 0. Because the factorial of 0 is defined as being 1. That's just the consensus. There's not really any logic behind it. Else, we say n times factorial n minus 1. Right, so we have a nice recursive implementation of our factorial function. Now, if I say factorial 3, this will work and it will give us 6. But this is unsafe, among other things, because if we do a minus 1, what will happen is we start already below 1, and then we just keep decrementing ad infinitum until essentially we run out and we exceed the recursion depth, right? Factorial calls itself so many times that Python basically is exhausted and it crashes, right? So if I run this, we will get a recursion error because we go factorial minus 1, factorial minus 2, minus 3, etc., until at some point Python crashes. Now, so it makes sense to make our function safe, right? So what we can say, for example, if n is smaller than 0, if n is a negative number, then we raise a value error. Now, why a value error? Well, a value error is one of Python's standard exceptions, right? One of the exception objects that are just built into Python. And it is basically, you're supposed to use it whenever you have a variable or an argument or whatever that has the correct type, but the wrong value. And that's the case here, right? Because minus 1 is the correct type, it's an integer, but it just has the wrong value because it's negative. So, and then we say value error cannot, factorial expects non-negative integers. right? And now we get a value error, so it still crashes, but we get a more useful error message, right? Factorial expects non-negative integers. Now, so it can make sense to raise your own exceptions essentially as a courtesy to the person who will be using your function, right? If we did not raise this value error, it could be quite confusing for someone else who is using our factorial function why we get a particular error message, right? Because this recursion error is kind of unclear, it's kind of weird. So whereas now we raise a value error that very clearly indicates to the user of our factorial function that we're expecting a non-negative integer. Right, so that makes a lot of sense. Now, and I think whenever Python's built-in exceptions do the job, for example, we have a value error, we have a type error, we have a name error, an attribute error, etc., you should use them. But you can also create your own exception objects if you want to. Now, an exception is just a class. And if you want to create your own exception, you can do it as follows. You can say, okay, class, for example, a factorial error, right? And that class has to inherit from exception or from another class that inherits an exception, right? So the exception object is at the basis of it all. And then we don't have to do anything else. We just say pass, right? So we only define basically almost a dummy class that inherits from exception. And then instead of raising a value error here, we can say, okay, raise a factorial error. Up. And now we get here, you see below, factorial error, factorial expects non-negative integers. Now, why would you do this? Well, again, it's all about communication, you know? So if basically the error, you have a piece of code and an error that can occur that is not very well described by, for example, a value error, type error, etc., you can define your own exception message to do the job for you. For example, if you have a database connection, and an error occurs in the connection, you can, for example, create a database connection error, right? It kind of indicates that something went wrong with the database connection. So in those kinds of situations, it makes sense to define your own exception objects, your own exception classes. But in the vast majority of cases, I think it's best style to just use Python's built-in exception objects, because there are plenty. Now, basically, that's all there is to know about exception objects in Python. Thank you very much for your attention.